So the biggest difference between experimental versus theoretical is that theoretical is what you think should happen. It's a theory, it's a possibility, it's what do I think, what should happen. So spinning this spinner, you see how all the sizes, how all the numbers have exactly the same size in the spinner. So we should get each number the same amount of times. Experimental probability is when you actually do the thing that you were thinking about. So theoretical, it should happen about 1/5 time. Excuse me. Experimental probability is once we actually spun the spinner, what did we get? So as we read this, it says Miguel spun the spinner shown 100 times and recorded the frequency of each result in the table. Use the information to drag and drop the pieces to complete the tables below. So because he has now spun the spinner, this information over here is what we call experimental probability. So we had 20 ones, 18 twos, 22 threes, 24 fours, and 16 fives. Theoretically, they should all be the same number if spent 100 times because 100 divided by 5 would be 20. So each one of these should be the number 20, but they're not. This 2 right here could have gone to the 2, and this 4 right here could have gone to the 5 to make them all even. But probability isn't always perfect, and that's okay. So let's go with the theoretical, what I think should happen. So the theoretical probability of spinning a 3, well, there is only one 3 here, so it would be 1 out of how many options? 5. So 1/5 would be an option I would click and drag up here. Spinning an even number, well, 2 and 4 are even numbers, so that's 2 out of 5. So I would take this 2 out of 5 and put it here. Spinning an odd number, so since there were 2 odds, that means there's 3 evens, so 3 out of 5 would be my theoretical probability for spinning an odd number. Spinning a number less than 5, there are 4 numbers less than 5, 4, 3, 2, and 1, and there are 5 possible outcomes, so that would be my 4/5. Now these 50s and 20s and 25s are going to be our theoretical or experimental probability. So spinning a 3, how many times did they spin a 3? 22. Now there are no 22s up here, but we know that he spun it 100 times. So we would make a fraction. You can't see what I'm writing, but I'm writing it, so I would put a fraction of 22 over 100. And then let's see if I can do over 100. And because those are both even, they can be divided by 2. So if I divide the top by 2 and the bottom by 2, so 2 over 2, 22 divided by 2 gives me 11. 100 divided by 2 gives me 50. So can these be simplified anymore? Nope. So I'd look over here. Oh, there is an 11 over 50. So this would go in the experimental spinning a 3. Spinning an even number. So evens are 2 and 4. So we have 18 plus 24. And we would find that total. So that's 12 and 4. So 42 out of 100. And again, these are both even, so we can divide by 2. So if I divide by 2 over 2, 42 divided by 2 is 21. And 100 divided by 2 is 50. So it'd be 21 over 50. So this guy right here, click and drag. An odd number. Now those are all the other numbers. Because we already have the total for even, we don't have to do all this math for odd. All we have to do, I'm going to choose a different number, or color, my goodness. All we have to do is, since there were 100 spins, we could take 100 and we can subtract the even numbers. So there were 42 even spins. So now what's 100 minus 42? Well, the 10 becomes 9, the 10 becomes, or 0 becomes that, and we get 58. So we have 58 possibilities. So 58 divided by 100. Again, they are both even, so I'm going to go ahead and divide by 2. 58 divided by 2, I don't know that one off the top of my head, and 5 isn't an even number, so I'm going to use my calculator. 58 divided by 2 gives me 29. So 29 over 50. Right there. Boop. And so then process of elimination means the last one we have left is 21 over 25, which would be this number right here. So that is how you figure out experimental versus theoretical probability.